at steganography, how to detect it, hidden data in file structures, and looking at trail obfuscation. They want to block you from following that trail. We're also going to understand the techniques of artifact wiping and overwritten data and metadata overview of some of the countermeasures that you can take and some of the anti-forensics tools. Let's start with understanding anti-forensic techniques. So what is anti-forensic? Sometimes called counter-forensics. It is a set of techniques that help make it harder for you to do your job. They complicate or prevent the proper investigation process. So what the attacker, the hacker, whoever it is trying to do is try to interrupt and prevent good data collection and make your investigatory tasks more difficult, hiding their activity, compromising the accuracy so that when it comes time to report or give testimony, it is corrupt. And so they want to delete any evidence that any anti-forensic tool was even used. They're covering their tracks. They're making it harder for forensics teams to do their jobs. There are a plethora of anti-forensic techniques, including probably one of the most common ones is just deleting the file, or doing password protection, or hiding data stenographically or in file system structures like alternative data streams in NTFS, or trail obfuscation, taking those artifacts, wiping them, overwriting the metadata or the data, using encryption. Well, I can't crack the encryption, you can't see what I'm doing. Also taking a program and packing it to make it look like something else. Minimizing the footprint, just tiptoeing through the system so you can't find it. Also exploiting forensic tool bugs. So if they know that a specific forensic tool is very often used and it has a specific bug, they can make use of that knowledge to hide what they're doing. Deleting a forensic tool activities. They were using a forensic tool and now they're going to wipe the fact that they were doing that. So one of the most used, I would say, anti-forensic techniques is data file or deletion. So what happens when a file is deleted from the hard drive? And this is something I was mentioning in a previous module. When you delete a file, the pointer of the file gets deleted. That's it. It's like removing the card in a library that shows you where the book is. So instead of taking the book out and tossing it in the garbage, the book is still there. You just take the card that represents the location, the shelf and the floor of the library, and you just delete that card. So the data is still there, just what refers to the data and the data's location is gone. So a deleted file can be easily recovered from a hard disk until those individual sectors that have the data get overwritten by new data. So since I'm telling the operating system that there's nothing there, the operating system will start writing into that space where data actually exists. It just is not in reference on the disk. So tools like Autopsy or Recover My Files or EASUS or Wizard Pro or RStudio, I've used a lot of these before. Probably the one that I use the most for just small jobs would be Recover, which is spelled with, doesn't have an R at the end, so it's Recover, V-A, Recover. So lots of tools can help you do that. Commercial tools, free tools, open source tools, various types. So we were talking about that deleted file and how we don't actually delete the data when a file is deleted in Windows. There is a way to wipe the data off, but for the most part, it's not. In a FAT file system, what the operating system does is replace the first letter of a deleted file name with a hex byte code. And so you can tell the file was deleted because you see the E5H hexadecimal code. So it's a little tag that says it's been deleted. And so when you look at that cluster, that fat is marked as unused. So it says this cluster is unused, even though it actually still has the information. All right, for NTFS file systems, user deletes a file. It just marks the file entry as unallocated. Again, the file contents are still there. So the cluster is allocated to the deleted file. They're marked as free, so you can store new data there. And then you have a $bitmap. The file is recorded and used for used and unused clusters. So whether it's used or unused, it's marked as free in the $bitmap. The computer now says, hey, that's empty. I can use it. I can store stuff. And the deleted file can be recovered if it hasn't been overwritten by other processes. And so also, one of the things I use quite often is this one. On a Windows file system, when you do a normal delete, it sends it to the recycle bin. So let's say that I've selected a file in Windows in a folder somewhere, and I hit the delete button on my keyboard, or I right-click on it and hit delete. It goes to the recycle bin. Now, I hate having a super crowded recycle bin, and so what I always do is I always do a shift delete. And the shift delete puts nothing in the recycle bin. It deletes it 100%. However, just like any file that's deleted, when you go to the actual hard disk structure, the NTFS file system structure, again, even if you do a shift delete, you bypass the file, the file bin, recycle bin. You bypass the recycle bin, but still the pointer is deleted, but the file is still there. All right. So shift delete, bypass file bin, regular delete goes to, I keep saying file bin, but what I mean the recycle bin. All right. So we bypass the recycle bin with shift delete or delete. It goes directly to the recycle bin. So let's talk about the recycle bin. The recycle bin in Windows. What is it? It's a temporary storage place for deleted files. So if you've deleted a file, it's going to be in the recycle bin, and it's going to stay there until you empty the recycle bin or if you restore the file. So one of those two. So if you want to restore a file, you can put it right back to the way it was and put it back in the recycle bin. Now, there is a caveat to this. If you have a network drive or a flash drive, USB, you can permanently delete the file because the file, the recycle bin doesn't apply universally. It doesn't apply to network drives or USB drives necessarily. So be careful with that. The recycle bin is a storage location depending on the OS and the file system. So in a FAT system, Windows 98, remember Windows 98? Or 98 was really an interesting OS back in the old days based on DOS. It's under drive::recycled, so C::WAC recycled. On 2000 NT XP, it's in drive::recycler with a SID. And on Vista and later, it's in drive::recycled.bin with another SID, a security ID. All right, so if we look at a file that's been deleted, the complete path of the file, the name of the file is stored in a hidden file called info2. That's back in Windows 98, in the recycle bin folder, and this is needed to restore the file to its original location. So before Windows Vista, the file bin was stored in its physical location, the drive letter, # or hash, the original extension, and that D says it's been deleted, so a D in front of it. An example would be D. That means it's been deleted, e7.doc, and it's an 8th file received in the recycle bin, and it's a doc file. So this is like a small version of that name. With the recycle bin in Vista and later versions, if you have a deleted file, it's renamed to $R, and then a number, that little hash or # is a number, dot the original extension where that little hash or # represents some type of random letters and numbers. So at the same time, you have a metadata file that's created, and it has a $I and a number, random number letters, dot the original extension, and that pound sign or hash represents random letters and numbers that are very similar, used for $R. And so both $I and $R, both of those, are located in the C: whack $recycle bin, whack, and then the user's SID, security ID for that user. So $I contains the original name, file size, the date and time that the file was deleted. So that's the metadata that's in $I, and that you get that information from $I. So in terms of recycle bin forensics, we want to look for the original files that are linked to that $I file. Remember, they're not visible in the recycle bin folder if $I has been corrupted or damaged, or the insider, who could be an attacker, or the attacker who has made it to that system, deletes that $I file from the recycle bin. So when you're running your forensic investigation, you need to check for the $R in the recycle bin, and that will help you counter the anti-forensic technique that's being used by the attacker. And that technique is to delete $I. And so here we go in the recycle bin, and we see we have right over here, we have $I files and $R files. So INR audio files, and we see that listed over here. But we go over to number 2 here, and in this case, the recycle bin folder contains only files that have a $I. All right, so we need to be able to determine what the attacker has attempted and then counter those counter forensics. So if the metadata file that's related to the original files is not there at all, then we can use a copy command to recover the deleted files, these $R files. So we copy and we give it the path to the destination directory. So here's the copy command in action. We're going to zoom in on it there. And so we see we're copying $R star. That little asterisk or star means everything that begins with $R. And then there's a space, that's the source to the destination of d:/whack recover. So we're going to recover anything with a $R, copy it to the destination location. Once we do that, then we'll be able to see the recovered data in the recover folder, and we're ready to go. Right? So we are now been able to recover that data that was forensically hampered by the insider or the attacker trying to hide that from us. But I will say this, though, that if you can't recover the data from the recycle bin, you always can go to the file system, which we'll see in just a little while. File carving. And what we do with file carving is we use this technique to recover files and fragments of file from the hard drive in the absence of metadata. So we don't have any of the metadata that tells us what's going on. We're just going to identify and extract, looking for specific characteristics like header and footer information of the file rather than extension information or metadata information. So what we're looking for is a file header. It's a signature, often called the magic number, which is a numeric, it's a constant, it's a text value that gives us information about the file format. So there might be an attacker, a suspect, who's trying to hide an image from being detected from investigator by changing the extension from JPEG to DLL. However, if you do that, it doesn't change the file header. And you can go grab that file header information and find the actual format. So let's say you have this JPEG. It's a JFIF, shows as JFIF in the file header. It gives you that signature, and you know exactly what kind of file it really is. So you take a look at the file headers and verify those formats. There are tools that can help you with this, like 010 Editor, CH Hex Viewer, the Hexinator, Hex Editor Neo, Quick or Hex View. There are a lot of them out there that can help you get this information. So when you are specifically file carving on Windows, there are things that you can do. What Windows does is it tracks its files and folders using pointers in the file system. So let's say you're using NTFS. There are pointers to the files on NTFS. So when you delete a file from the hard drive, the pointer gets deleted, but all the contents are still there. So you can recover them until they get overwritten using tools like Autopsy, Recover My Files, Easus, RStudio, Recover, like I was talking about before, and it can be used for recovering those deleted files from Windows. So here's Easus. You run these recovery tools, they go through and they look for the files, and they give you the names of the files, and a lot of them, what they'll do is give you a list of all the files that have been found and the level of recoverability. So if there's been a format, delete, partition loss, OS crash, or whatever, you can run these tools. Let me give you an illustration. In the 90s, there was a president of the United States of America that was having inappropriate contact with a young lady. All right, so I'm not going to give any names here. You can look it up yourself. Anyway, there was an investigation that took place, and this investigation was closing in on the suspect. And so she realized that an investigation was taking place. And so what she did is she formatted her disk drive, formatted the whole thing, got rid of all the data, at least she thought she did. And when the investigators arrived and confiscated the information and started their forensic recovery, they simply unformatted the drive, recovered the data, and the rest is history. There have been many times when people have tried to do anti-forensic techniques like that, delete files. In fact, there's another case that happened about almost 20 years later, where a woman who was she was working for a company in around 2015, 2016, and she was putting in so many hours. This was a small, fast company, and it was too much work. I don't even remember what her job was, but she was pulling late hours and early hours, and she went to her boss and said, "Hey, boss, tell you what, I'm working too hard. This is too much. I need somebody else to help me." And every time she talked to her manager, they kind of made hems and haws. They didn't actually do anything about it. And finally, she decided that she really had enough, and she was going to start looking for another job. So she pulled out the jobs page online, or could have been a newspaper, I don't remember what. But as she's looking for jobs, she just went ahead and looked for her exact job type. And she found a job listed. Oh my goodness. The job listed was at her company for her exact job. And she thought to herself, I can't believe these people, after putting in all those hours, working so hard, they're going to replace me and they're not even going to tell me about it? Well, I'll get them. So a little while later, with the access that she had available, she deleted all of the critical business files of the entire organization. She got them. And as she was arrested and being taken to being processed for her criminal activities, she found out that they were hiring that second person that she had asked for. Well, anyway, she had deleted everything, and the company brought in somebody like you or like me, and guess what they did to all those deleted critical files of the company? Yep, they undeleted them, and the company went on just fine. So these kind of recovery tools, very powerful, very useful. If a disgruntled employee deletes all the files, you can undelete them. If somebody formats a drive, you can still pull all the files off of it. Because remember what we say, those files, only the pointer to the file is changed to say that there's nothing there, but the file itself is still there until other processes and files randomly overwrite it. Now let's go to file carving for Linux. So Linux, as we talked about before, makes use of much different file system and hierarchies than Windows. So we need to talk about some of the differences. And so when a file is deleted from Linux, if you use the command binrem in the inode, pointing to the file gets removed, but again, the file remains on the disk until it's overwritten. All right, so the RM is for remove, right? If you're running a process that keeps a file open and then removes the file contents are still on the disk. And actually, even other programs won't reclaim that space. So it's a different than deleting the file versus a process running the file. It's required, we really need to note that if an executable erases itself, like a binary is running and it erases itself, you can go to the proc memory image and you see p proc, etc., creates a copy of the file in temp. So you can still retrieve some of that data. There are third-party tools that you can use in Linux, such as Stellar Phoenix, Linux Data Recovery, RStudio for Linux, Test Disk, PhotoRec, Kernel for Linux, etc. There are many tools that you can use to help recover files from Linux. Now, if you have an SSD and you're running an SSD on your Linux file system, there's a forensic workstation that you can use. So you can actually do it from Windows 10, and you can forensically acquire the image from trim and disabled SSDs. You examine them using Autopsy or RStudio. And so in Autopsy, you can use data carving tools. You can look at the carved data from the forensic evidence file, and you will find it, if you see right up here, carved files 6. And so you can look under that heading and you can see the data that was carved. And also underneath the deleted files, you can see the deleted data that's recovered that you end up recovering from the SSD. So there are tools that you can use to recover it. But what if somebody deletes the entire partition, right? So you have an MBR partition. This partition table contains all the records of all your primary and extended partitions. And when the partition is deleted from the disk, all those entries that talk about where that data is on the disk is deleted, removed. So you need to use a tool like EaseUS or RStudio, and then you can scan the disk, find the lost partitions, and recover them. Absolutely, yes, you can. So you can find deleted partitions, reconstruct the partition table entry for the deleted partition, and you are back up and running. And this is just showing you an example of that. So over here, we have an unallocated partition right there, 1.17 gigs. And as you can see, it's suspicious. Look, it's between two separate partitions. Normally, the unallocated one is going to be at the far end to the right, but it's in between them. So we find that unallocated partition, and then we can use a tool like EaseUS. So if you go over here, we are using EaseUS Data Recovery Wizard, and we see, hey, look, there's a 1.17 gigabyte lost partition. So then let's go ahead and recover that partition. In fact, you can open up and look at all the different files. Oh, look, there's Tweety. I had missed that so much. And so all these different symbols and whatever, all the files that are located, these are all images, I guess. And sure enough, you found them. You found them. You can recover FAT and TFS systems with EaseUS. Now, what about password protection? So you're running your forensic investigation. You're on the suspect computer, but you have password protected resources. And what are you going to do about that? This is a challenge that you might face. And so what we want to be able to do is get through that using password cracking tools. There are a lot of them. Offcrack is a tool that you can use. It's open source. Rainbow Crack is for rainbow tables. And either way, there are a lot of them that you can use to circumvent the password protection of that. So there can be several different types of passwords. If it's clear text, that's easy. All you have to do is reveal the stored password. If it's obfuscated using algorithms, and then we want to try to reverse that algorithm, or if it's hashed, we need to find the signature, that hash of the original password. We have to discover the algorithm too that was used to hash, including MD5 or SHA or other hashing algorithms. So how do we do that? There are many different areas. There are three major areas. Dictionary attack. And with a dictionary attack, you can use a dictionary. If you go online and you download, there are password dictionaries that have billions of passwords. In some cases, you want to use some of the most popular and just use a few thousand passwords. But it takes a long time. And what even takes more time is a brute force attack where you try every combination of characters until you break the password. And because of the linear process and the mathematical method that is used for brute force attacks, those can take so long that you could use up literally, you could use up all the computer power on Earth and all the time left in the universe and still not crack a good password, a passphrase. Quantum computers are probably going to make that not the case so much so in the midterm future, but right now brute forcing is very difficult to do for most passwords. The next one we have is a rule-based attack, and this is when you have some type of information about the password already, and that can be used to help you crack the password. For instance, you might know that the password has for every single employee, it has the employee number that's on their badge, dash some random password. So if I know that, then I have a rule, and I can use that to shorten my password cracking needs. There are tools that can help you with password cracking. So let's say that you want a professional tool that can help you with all kinds of password cracking needs. Password kit for the forensic kit for called Password is very good. File passwords, file encrypted passwords, memory analysis, internet or network. Look at this. Full disk encryption, and maybe even cracking that. Windows passwords. So it gives you a whole lot to think about, different places to go. LoftCrack has a few choices, not as many as Password Forensic Kit. OffCrack really focuses on Windows standalone, specifically the SAM, the Security Account Manager, passwords that are using LM-based hashes. Cain and Abel, it's no longer maintained. The entire thing, its project is no longer maintained. However, it's still a good tool, and you can go back and fish it out from archives and use it for cracking passwords. Rainbow Crack and the offline anti-password registry editor, lots of really cool tools for cracking passwords. Another anti-forensic technique is steganography. Steganography is when you hide an image, I'm sorry, not an image, when you hide a message in a cover medium. You hide a message in a cover medium. And that cover medium could be an image, but it could also be a document, or it could be an audio file, or it could be a video file. It's any type of file that you can imagine, as long as you have an embedding function to hide that image. And then once you've used an embedding function to hide that message in the cover medium, then it becomes what we call a stego object. And that stego object, for instance, I might find a forum that there's a picture of a castle in Scotland or something like that. It's a beautiful picture, and it looks like it's just people posting beautiful pictures to the forum or whatever. But in reality, it's a message for somebody somewhere else in the world that goes to that forum, and they have the extracting function, and they get the beautiful picture of that castle in Scotland, and they extract the message from the image, and it says, hey, meet me at McDonald's for a burger or something like that. So using steganography, an attacker can hide information. What kind of information might they want to hide? Well, maybe they have discovered information in your organization and they're now trying to exfiltrate that. Like, for instance, you could steganographically encode a list of 150 credit card numbers and people's names, and then you send it out as a JPEG, and the company has no idea. They just think it's an image, but in reality, on the other end, it's decoded and you have stolen credit card numbers. So something like that. So if you want to detect steganography, there are many nice tools out there. I've used many of these, probably mentioned about 5 or 6 more, and there are many more than that. But OpenStego is very nice because it looks for data hiding and digital watermarking and files. So you can help extract hidden data. There's also StegSpy. It identifies a steganized file and detects the steganography of it. So if you want to find a steganography in use in a specific file, you can use these 2 tools and others. Here's a sneaky one. It's called ADS, or Alternative Data Streams. And we've talked a little bit about the Windows file system of NTFS, which is actually a very nice file system. And it's pretty resilient, it holds up well, it stores files well, but it has features. And one of the features it has is the ability to create what's called a file fork. And so this is how you would do it. If you had a command prompt open in Windows system, and you would type in notepad filename.txt : hidden file .doc or .txt. I guess you can do txt also. So that colon says the file after this is going to go to an alternative data stream. So if you added 5 megabytes to the alternative data stream, and then you did a dir to list out the file contents in that folder, you would not see that 5 megabyte file anywhere. You would see the root file, not the one after the colon, but the root file, and it would say 0 bytes. So the attacker can hide any number of streams into a single file. So I could do file.txt : stream1.txt, file.txt : stream2.txt. So I have the same root file, but I have 13, 15, 20 different hidden files. And the root file still is the exact same 0-byte text file, even though I have 20 alternative data streams, each one of those having lots of information in them. So the file and date stamp can be modified using anti-forensic tools like timestamp. So in some cases, these hidden ADS files can be used to remotely exploit a web server. So for instance, I can take an executable. Let's say that I have a malware. What I can do is I can take the malware.exe, and then I can use a directional operator, or I can print it to the screen. So I could print malware.exe, then use the greater than sign, and then have file1.txt : backdoor.exe, and I can move the malware executable into the executable alternative data stream. Anyway, it gets complicated, and either way, it can cause it to allow remote exploits by attackers. So you have to be very careful with alternative data streams. So another anti-forensic technique is trail obfuscation. So if you're walking in somewhere and you wanted to cover up your footprints, you can grab a tree branch and you obfuscate the fact that you are walking in that location, right? If you are a criminal and you go to a break-in location by picking a lock, and then you go grab something, and then you don't want anyone to tell what's going on, you can obfuscate your trail. You take all your fingerprints and wipe them off, and then maybe go delete the files from the camera. You're obfuscating your trail. But in computer systems, we use things to mislead investigators. We can do log tampering, false email header generation, timestamp modification, and some of the techniques would be cleaning the log, get rid of it, right? That's we saw log tampering right there. Misinformation, misdirection, spoofing, zombie accounts, Trojan commands. And so you can obfuscate traffic by using VPNs. So it's all encrypted traffic, or SSH tunneling, all encrypted traffic. So in other words, the attacker is using many different techniques to try to obfuscate the fact that they were there. They don't even want you to know they were there. Not only that they tampered with or exfiltrated or ran executables or whatever. Trail obfuscation. So Timestomp, like I mentioned before, is one of the most widely used trail obfuscation tools. What does it do? Timestomp. Sounds like it's like stepping on a stopwatch or something like that. But what it does is it allows the deletion or modification of the timestamp information on files. Defeating this technique, you want to detect overwritten metadata, right? That's what you want to do. Because what the attacker is doing is, let's say that they launched an attack at 10 a.m. On December 1. And so what they want to do is change that timestamp so it doesn't match any of the records of the system. And over here we just talk about using that timestamp. Just goes through the step-by-step there. Another anti-forensic technique is just to get rid of the artifacts. Wipe them. Permanently delete files. So a couple of ways of doing that. Number one is disk wiping utilities. And so it erases data by deleting the links to memory blocks and then overwriting the contents. So BC wipe, total wipeout, secure cyber scrub, driver scrub, rubber, shred it. Another one is file wiping utilities, and this deletes individual files and file table entries from the OS. And those include BCP wipe, RWipe, CyberClean, etc. And a lot of these will actually also write ones and zeros over and over and over again. On top of that data. Another one is disk degaussing destruction. And so with a disk, even with, depending on whether it's an SSD or whether it's a rotational mechanical drive, if you look at the rotational mechanical drive, you have a like an aluminum platter, and then you have like a mylar substrate that's or it's actually doped, so it actually has ferrous oxide coating that allows electromagnetic field. So when the disk is moving underneath the read-write head, if the read-write head fires, it raises a magnetic 1, right? If it doesn't, in that sector, it's a 0. If it fires over here, it's a 1. So as this substrate moves past, we have 1s and 0s that get written onto there. And so what is it? It is that ferrous oxide, it is charged by the read-write head to be either a 1 or a 0. So what you do is, instead of having that little micro disk, that current to write ones and zeros, we get a gigantic electromagnetic field that moves, and we run that across the entire disk, a super powerful magnetic field. And what that does is it scrambles everything on that drive, completely cleaning the device of any stored data. So the NIST also recommends a variety of methods to physically destroy the media, including disintegration. So if you happen to have 100 acres, you can go take a stick of dynamite and tie it. I don't recommend this, though. I don't want anyone to get injured. But pulverizing, shredding, you can buy shredders that shred disk drives. Melting, even. You can heat it until it melts. And that's something that routinely is done. So intruders use degaussing destruction techniques to make the evidence data unavailable. So how do you, if somebody shredded a hard drive, here is the technique we use to unshred it. There isn't one. You can't unshred a hard drive. You can't unmelt a hard drive. Sometimes the data is just gone. Well, the next anti-forensic technique would be in formatting. It doesn't erase, it just wipes the address tables, and we can recover that. All right, so if somebody shreds a disk, unless you have a time machine, and you can go back and get the drive before they did it. If you do get your hands on a time machine that you can do that with, please let me know, because I'd like to go on that little journey. But there are no time machines. You sometimes can't get the data back. So it's difficult to retrieve data that's been wiped out using these techniques, so it's recommended that the organization keep a backup of the data on a regular basis. So that's where we go. And so what's going to happen is the perpetrator is going to steal the disk from the computer that they were hacking on. They're going to take it to their lair, right? So if you're a hacker, it's not your house you're working out of, it's your lair, because you're evil. And they'll take it and they'll degauss it and they'll shred it. And so when the police investigate They can't find any evidence from that. But there was a diligent organization that not only was backing up the data that the user used, but they were taking periodic images of the disk. So you go to the latest image that was taken by the organization, and then you can use that for your investigation. So having good backups, and especially image backups, can be extremely helpful if you can't recover the data from the layer of the attacker. All right, next we look at overwriting data metadata. We mentioned this a little bit before, but one of the anti-forensic techniques is when the perpetrator will use different techniques to overwrite the data. And it can be really difficult to recover from that. They might overwrite the entire media, individual files, or delete them, or overwrite the metadata to create a different timeline. Sometimes when this is happening, it might actually draw the attention of the organization or the investigators. And so they're going to try to cover those tracks. So they might use timestamp, which you can get. Again, we talked about it before. It's part of Metasploit. I didn't tell you that before, but it's actually very interesting. And they were going to change with timestamp. They're going to change the MACE. The MACE, yet another acronym for you. The modified access created entry attributes of the file to try to fool you and stop you from recovering the data. There are ways to recover data after timestamp. We talked a little bit about it before, but this is one of the anti-forensic techniques that attackers use. The next anti-forensic technique is encryption, and this can be very difficult to overcome. So it is there to defeat your investigatory process. They use strong encryption algorithms like AES 256, which make it very difficult without having the key to unlock that file, to decrypt it. And most encryption programs can do other things like full volume encryption, plausible deniability. It makes it much more difficult. Cryptanalysis can be used to decrypt the data, like Cryptool. It's possible, just remotely possible. If you are in a country that uses government access to keys, it is likely that at the government level, you would have the key to those encryption algorithms and you'd be able to decrypt the drive, but not at the private level. All right, now we look at discussing countermeasures for anti-forensics. So what are some countermeasures for anti-forensics? One is to train and educate forensic investigators. So your team needs to know about all the anti-forensic possibilities so they are ready for them. You need to validate the results of the examination using multiple tools. You're looking at it from multiple vantage points, and impose strict laws against the illegal use of anti-forensic tools. Now, I don't know about you, but I'm going to go ahead and make a law right now. I'm just kidding. My point is, you can't make a law. You have to actually have that passed at government level. But you can have a policy in your organization that is very strong to help discourage that. Number 4, understand anti-forensic techniques and their weaknesses, because not every anti-forensic technique works. I gave you the example of the person formatting their drive, right? That was an anti-forensic technique, and on the outside it looks successful, but in reality it's not. Use the latest updated CFTs and test them for vulnerability. So you want to make sure that your tools don't have vulnerabilities. Here are some of the most popular anti-forensic tools. A lot of these deal with steganography. So Steganography Studio, CryptoPix, it's an image file management and encryption tool. Oh, there's my laser pointer right there. Gilasoft FileLock Pro. This is one where you can hide messages in folders. So for instance, if I open up a folder and I have 10 files in it, I might not know that somebody used FileLock Pro to hide 30 hidden files that I can't even see. They're without FileLock Pro. WP Stego, Data Stash, OmniHide, Masker, Deep Sound. Deep Sound is actually interesting because most of these, like Steganography Studio does several different types of steganography. CryptoPix is really mainly used for images. FileLock Pro is mainly used for file folders, but Deep Sound is for hiding steganographically encoded information in sound files like MP3s. So you tell one of your friends, hey, here's the latest song I wrote, or have you heard this song? And it's an MP3. But the MP3 actually has an entire set of messages encoded into it. You can also encode messages into videos too. DBAN and East Tech Invisible Secrets. These are all anti-forensic tools that can not only help you do encoding, but decoding of forensically hidden messages and people who are trying to exfiltrate data, etc. You can detect those and begin the process of decrypting them. So what we've seen is that the attacker, the insider, whoever it is that is running a criminal act against a computer system, they're going to very often try to hide their activities. And the fact that they're trying to hide their activities and derail your investigation is called an anti-forensic technique. So we looked at everything from the file system level to the file structure level to carving techniques. We looked at password and steganography and artifact wiping and a little discussion on some countermeasures and some tools that you might want to use. These are all very nice tools. So that brings us to the end of this topic. What we're going to do in the next module is we're going to get into some detail on a specific operating system, that is Windows forensics. Join me in iLabs. Want to do some labs, get some hands-on experience, and then join me for the next module.